Hello friends, today we are going to see a problem related to system of parallel forces. So this is another force system which is very important from examination point of view, system of parallel forces. Now you know this that the forces are parallel to each other like this. These are the parallel forces, right? So they are classified as number 1 like parallel forces. It means the forces which are in same direction. If they are in same direction, they are called like parallel. If not, it is called unlike parallel force system. For example, one force is downward, another is upward, again like this, like this. So this is called unlike parallel force system. I hope it is clear to you. So today we are going to see a small numerical on this which is appeared in D/2 examination, right? So I am going to take a first example which is appeared in exam December 2019. So problem is given. Just a moment. There is a beam and two unlike parallel forces are given. Diagram is given in the question paper. So I am having the same diagram here. This force is upward 100 Newton. This force is downward 400 Newton. And they have also shown the resultant force direction are at a distance x, and the distance between these two forces is given, that is 150 mm. So this problem is appeared in D/2 exam December 2019. This is for 4 marks. This is a small problem actually, and that's why it used to come for 4 marks only. So here what is to find? It has been asked to determine the magnitude of the resultant force and the point at which it acts, right? So this is what is asked. Now it is very simple. We know how to get the summation. So the first thing what we have to do to find the resultant, we know we want summation of fx and summation of fy. So let us take summation of fx first. Now there is no horizontal force or no force in x direction. So summation of fx is simply 0. but you have to show here in the solution. Second, let us have summation of Fy, all the forces in y direction, right? So there are two forces, okay? Don't include this r because this we have to find actually based on this forces given. So summation of forces with usual sign, I consider upward as positive and downward as negative, right? So it is 100 minus 400, so that is equals to minus 300 Newton, right? Or I can say it is equals to 300 Newton downward. You can write both the way. You can write like this or you can write like this also. It has same meaning. It means resultant R is equals to, as there is no fx component, no need to have a under root and all that, okay? Otherwise you know the formula to find R is summation of fx square plus summation of fy square, but as this component is 0 itself, we know the square of this and square root of will be the same. So we directly I can write R equals to 300 Newton with downward sign, which is already given in the problem. So you have a, you need not to worry with the direction also. Direction also they have shown in the problem. So it's very simple. Now we have to find the position of this resultant force from point A, right? Because the x distance they have given from A. So we know Varignon's theorem or principle of moment. So using principle of moment, which is what? Which is, moment of resultant force is equals to the summation of moment of summation of all the forces about the same point. So you remember that principle, right? So mathematically you can write like this: R into x is equals to f1 into x1 plus f2 into x2 and so on. So this is the theorem. I hope you remember this theorem. Okay, you revise it and try to understand so that it will help you to solve this particular problem. And this theorem is applicable in all the force systems. So you must know the concept of moment. Moment is what? Force into perpendicular distance. And principle of moment is what? The moment of resultant force about a point is equals to the moment of force about the same point, right? So let us have that application. So here we have one force, 400 Newton force is at A, so moment of this force is 0. Only we will get moment of R, that is resultant force, and moment of 100 Newton. Okay, and we know they are opposite to each other. So simply we will write R into X, because it is perpendicular distance is X. So R into X is the moment of resultant force about A point, which is equals to moment of force about the same point. Means we have to take a moment of 100 Newton force about A only, not about C. Okay, many students make mistake here, right? Follow the principle of moment, right? We have to take the moment of all the forces about the same point. Now point about which we have taken a moment of resultant is A, so you have to take moment of all other forces about A only. I hope it is clear. So the moment of 100 Newton is 100 into perpendicular distance is 150 mm, so 150. We know the R value, that is 300, so 300x is equals to 15000, and hence x is equals to 15000 divided by 300. Hence you will get the position of resultant. 20 has gone, So 150 divided by 3 is 50 mm. So this is very simple problem. So we got this x distance, that is 50 mm from A. So you can write here from A, right? So this is the solution of this problem. Now, as the time permits, let us have one more problem related to this so that you have better understanding. So I am going to consider another problem that is appeared in exam summer 2019 of D Batu exam. So I am writing here D Batu summer 2019. This problem is for again 4 marks, right? And problem is given here. Compute the resultant in magnitude and direction of a parallel force system as shown in figure. So figure is given to you. So let us have the figure here. So they have given 3 forces, okay, with a reference line. One, two, and 3. So direction of forces is given like this. This is downward and 60 Newton. This is upward with 20 Newton magnitude. This is again downward with 100 Newton magnitude. So from diagram itself you can see that this is a parallel force system, and that too of unlike type. It is unlike because this force is downward, this is upward, this is again downward. So this is unlike parallel force system. So the problem is for 4 marks. It is very simple. So just take summation of fx in solution, and that is 0 because there is no force again in horizontal direction. Summation of fy is equals to, with usual sign, I used to follow downward as negative and upward as positive. You can have your own sign convention, there is no difference. So summation of fy is what? Minus 60 as it is downward, right? Upward I am taking plus, so plus 20. Then 100 is downward, so minus 100. So it is giving me minus 140 Newton. Or as I told, you can write this as 140 Newton, and my minus sign is downward. It means this is downward, right? Hence, simply I will get resultant force R equals to 140 Newton. In previous example I told you how, because we don't have fx component, and that's why R is simply equals to summation of fy, and direction is downward. I hope this is clear. Now what we will do, we will find the position. So position of resultant force R. So let us consider from any one point, either from left force or from right force, right? So what I am considering this point as a O point, okay, at the left end, and I am showing this somewhere resultant force, and that is downward and I got the value also, so I will show in the diagram, and I will assume the distance between these two, that is O point, and the resultant force as x. I hope it is clear to you. And let us find the x now from the basic principle. Okay, so using the principle of moment, right, r into x, okay, is equals to the moment of other forces acting in the system about the same point. So now I am having the forces, that is 20 Newton, then 100 Newton, okay, 60 Newton is acting at the O point, so having no moment, but still I am writing for you. There is no need because it is 0 only. So now consider the sign convention. So clockwise I generally take plus and anti-clockwise minus about a point. So keep a finger here at O point and take a moment of 20 first. So it is going, in anti-clockwise fashion. So it is minus 20 into, the distances are given, 20 mm, and this is 30 mm. It is given in the problem. I forget to mention. Okay, it is required when you need to take a moment. So 20 Newton having 20 distance from O. So 20 into 20. Then this 100 Newton is going in a clockwise fashion. You can see it is going in a clockwise fashion. This was anti-clockwise, so I have taken minus, right? So plus 100. Now very important about the distance. You have to take perpendicular distance about a point or up to a point where you are taking a moment. So you are taking moment about O. So the distance should be complete distance. So it is 30 plus 20. It is not simply 30. Many students makes mistake here. They take simply a 30 mm distance and that makes wrong, right? So 100 into 50, right? So I hope it is clear. I have taken a 50 mm. Why? Because 30 plus 20 is 50. I want a distance of a force from O point. So that's what it is, a perpendicular distance, and it is addition of two distances. So it is coming, we know the value of R, that is 140, right, into X is equals to minus 400 plus, this is 5000, right? Let us have calculator. Minus 20 into 20 plus, or simply solve like this, 5000. So I get 140x equals to minus 400 plus 5000. It is getting 4600. Hence x equals to, divided by 140, it is coming to be 32.85 mm, right? It means R is at 32.85 mm from O point, or from 60 Newton force as shown in the diagram. I hope it is clear to you. So this question is for 4 marks. Very simple question. I hope it is clear. Thank you.